Okay, so if you want to be able to basically consider blockchain for any kind of service or project or use case, right? We first have to understand this. Blockchain presents many advantages. Some of them are the following: security, transparency, and trust. We'll talk more about this in the coming slides. Now, if you consider a traditional client-server application, or for any of your existing projects, or for a new project, think of it this way. You'll have to invest money and time and resources and efforts into building the application and then into securing it. So the first question that your management or your executive director will always ask you for any kind of a new solution is it secure, and how much is it going to cost me, right? So is it secure? It's one of the most important fundamental questions that we always get asked by management or by the executive directors about the security of the application, the potential threats, and how are we going to mitigate those threats. So in this case, a normal client-server application, even be it a web app or even a mobile app, the more you have to spend on security. You have to buy SSL licenses, secure socket layer. You have to purchase endpoint security. You have to purchase application level security. And then when your application grows in volume, you'll have to purchase additional layers of security on it, firewall security, and different layers of application type security aspects on that application, port securities, and so on. So as your application grows in volume, you still have to pump additional money into it to secure it, right? And that can be a very huge cost burden on the company. And that's what blockchain has a major advantage, because security is built into the blockchain network itself. Within the blockchain architecture, you have different security layers built into the blockchain framework. The secure hashing algorithm is only one side of it, right? So here we'll talk about how the security is built into the system, and in the section 2, the next coming section, we'll talk about the specific different layers of blockchain security that is built into the network itself, right? Which gives an advantage for you to be able to deploy your application on. All right, so let's go ahead and continue here. Okay, first, so these are the core fundamentals in blockchain, right? Security, transparency, and trust. And this is why blockchain solves the following problems in any kind of a project or an application or the design of an application, right? Security, transparency, and trust is embedded or built into the blockchain network. Here's how. First of all, trust. The issue with trust is the following. Traditionally, we have central control, right? Central authority. Every single bank, financial institution, insurance company, and every traditional company owns and maintains a centralized control of that data. Customer service information, accounting information, financial records information about that specific company or organization, employees' salaries, employees' benefits, and all that, right? All of that is maintained in a centralized control environment that's owned by that specific entity, right? So trusting a central authority is no longer viable. Why? Because the 2008 financial crisis proved that point to us, right? We can no longer maintain trust in the so-called banking system, right? Because the financial services, the economic crisis of 2008 proved that after we trust that system, that's what happened, right? Trust was violated by those in power, by those who are owners or custodians of that financial institutions. So now we have to take a look at the different model, decentralized control, right? We can no longer trust a centralized model. Now we have to look at different models that can help protect our interests and our investments as consumers. The second part is control. The risks of having central control over an application leads to corruption and fraud. Here's a big question. When you give unlimited power to a few individuals, and then they know they can get away with it by doing certain things, by changing, manipulating the system, chances are they may condone into malicious activities, right? Chances are. If a CEO of a company knows that he can do X, Y, and Z and get away with it, and he's going to be untouched, right? Chances are he may or may not condone and support illegal, malicious activities. But if you distribute that power, right, if you distribute that power and control over 10,000 individuals, and you say, okay, if you have 10,000 people, and the majority of these people have to be able to work together to be able to be convinced to manipulate or change transaction records into an organization. It's less likely that 10,000 people or 8,000 people are all going to be corrupt. It's the power in numbers, right? This presents a fundamental model or aspect of blockchain as a decentralized technology. There's no single entity that controls and owns the data. It's completely distributed, decentralized, right? We'll talk more about what that means in the next few slides. Audit firms, right? So audit firms basically here, when an audit firm issues their audit report for a bank, we accept it as is, right? We don't question it. But then 6 months later, like for example the Wells Fargo case and other banking fraud cases that happened, 2008 financial crisis of the banking's fraud cases, we now see, okay, what happened to these auditors? They were supposed to audit these financial statements and give us confirmation that their financial the financial is sound, right? The financial environment of that company is sound and stable. But then we realized it was all committed fraud. So what was the purpose of paying these accountants and these auditors? And this is what raises the question about trust now. We can no longer maintain the trust in the existing system thanks to the financial crisis that happened in 2009, thanks to the continuous aspects of fraud that we find in different financial organizations, across different banks, across different investment banks, and so on. Right? We can no longer maintain that trust, even though they go and they maintain regulation standards and requirements, and then they go and maintain their records with an auditing firm, and they issue the auditing reports, and they issue their shareholders agreements, and every year it still proves to us that there's a big gap in the market which we have to address. Blockchain presents many advantages. One of that is solving the problem of trust using decentralized and distributed computing. Okay, so this is an example of a company back in the UK in London. A Big Four firm, KPMG, has been stung with 7-figure fine by the UK's accounting watchdog following a lengthy probe into its audit of its Syndicate 218. Syndicate 218 was a insurance company based in the UK, and basically what happened was that KPMG accountants and auditors colluded with Syndicate's top management, and they basically inflated the financial records of the company. And a year later, it was discovered that they don't hold the right financial records as was stated by KPMG, and hence they were fined, right? The UK wing of international professional services giant KPMG has been hit with a £6 million fine and severely reprimanded following an examination by the Financial Reporting Council of its 2008-2009 audits of Syndicate 218, right? So essentially they were discovered. Again, this brings up the main point. We can no longer maintain trust in these audit firms because of cases like this. And cases like this are happening across the world, across different industries, manufacturing sectors, financial services sectors, investments, insurance, and so on. So we need something else to be able to maintain the trust of these organizations and for the stakeholders of these companies. The rise and fall of Dubai's Abraj Group. Dubai Abraj Capital was one of the largest private equity firms in the Middle East. They were holding assets north of $14 billion in assets, right? And now, 2 years later, they were going to complete liquidation. The top management has been accused of fraud and mismanagement of funds, and the entire executive board and of course they were using also another auditing firm, which every year that auditing firm was confirming in their audit report that Abraj Capital was sound and they were maintaining all their accounting records and everything was perfect. And then 2 years later, they're going to complete liquidation, and the management are being charged by fraud and mismanagement of funds and fraudulent activities on their transactions. Right? A lot of funds were missing. Over $384 million were missing, taken by some of the executives. So again, it brings up another big gap of why we should consider other technologies to consider for those specific use cases. Okay, so this is published by EY in 2019. 97% of business leaders recognize the need to demonstrate integrity in their organizations, right? This was published by EY as a survey between organizations across the Middle East. All right, I'll stop it right here, guys, and we'll continue on in the next lesson. Hey guys, welcome back. All right, we'll continue on the next lesson. So we'll talk now about transparency and confidentiality, which is the second aspect of the advantages that blockchain presents. So let's go ahead and continue here. All right. So the second aspect is transparency and confidentiality, which means that now blockchain, the public blockchain, which is Bitcoin and Ethereum, whenever you're making a trade of a Bitcoin or units or Ether, when you're buying and selling, here's what this means. The transaction that you do is completely transparent, which means that all the transactions of the Bitcoin network, when you're buying and selling Bitcoin with your wallet address, can be viewed on the Block Explorer, or in the case of Ethereum on etherscan.io. These are the websites which allow you to see all the different transactions that occur on the blockchain network for Bitcoin or for Ethereum. So for Bitcoin, it's a block scanner, and for Ethereum, it's the etherscan.io, which essentially shows you all the different transactions that happened all the way up to 2008 or 2015 when Ethereum was first created. In the case of Bitcoin, you can see all the transactions coming in since the start, the birth of Bitcoin in 2009, right? Now, this is a fundamental aspect because we no longer are hiding behind centralized control where everything is completely private. Transparency in the sense that the transactions are there, but there's no link to the identity of the person who owns that wallet address, right? So if I'm sending you, let's say 5 Bitcoins to your account, when I go ahead and do it, there's no link on the address, on my wallet address that connects me, my ID or my social security number or my birth certificate or my passport ID or my driver's license ID is linked to my wallet address on the network. When I go and create a wallet address on the Bitcoin blockchain, all I need to do is put a code, and they will assign me a hexadecimal code which represents my wallet address on the network. And then I go and deposit funds into it, right? Through their cryptocurrency exchange, right? In case of Binance or any other cryptocurrency exchange that you sign up with. When you transfer the funds into it, your wallet address on the Bitcoin blockchain is only as code. There's no ID or link to your identification, which is a powerful way. That's when we say confidentiality, because your identification is being owned by you, not by the system, as opposed to any bank or any financial institution where they own your ID and they're linked to your account. Now there are some big advantages in this case, like for example, when a major bank announces their private banking business just grew by $2 billion or $3 billion, or private equity business that just grew, they just signed up some ultra high net worth individuals, and so now they increase the private banking from like $2 billion to $4 billion. This attracts a lot of negative attention. Hackers across the world are seeing this. Now they know, so Bank ABC now just increased their private banking to $4 billion. Let's go and attack them. Let's go and approach them. Let's see what they have, right? You become an easy target for hackers. So what does the bank have to do? Invest more in security, invest more in protocol security and application layer security to protect their systems from these potential hacks, right? In the blockchain world, the transactions are public, which means that transactions can be viewed by anybody, but nobody knows it belongs to you, right? So in the case of public and private blockchains, we'll talk more about that in detail later on. The transactions are private within our permission based on user access and based on the entities involved. And so for example, today's DBA, database administrator, or let's say a system administrator, or basically your tech support, they have complete control over seeing your entire database of applications and your transactions and your employees' salaries and your, for example, your email services and so on, right? They have full access. And that becomes a big risk. If that person gets fired or terminated unexpectedly, then that person can hold a lot of information about you, and they can expose you to the public or to mainstream media, which can be very detrimental and high risk to your organization. Now, that's the key advantages, right, about what blockchain is: confidentiality and transparency in blockchain. All right, I'll stop right here, guys, and then we'll continue on the next lesson to talk about security in the blockchain network. Hey guys, welcome back. Okay, so the third aspect of the fundamentals of blockchain, which makes it very attractive as a technology, is security. So now we're going to be talking about security and how it plays an important role in the built-in architecture of what blockchain offers. All right? Okay, so as we said earlier, the first was transparency and confidentiality, or sorry, the second was transparency and confidentiality, and the first was trust. So trust, transparency, confidentiality, and the third aspect is now security. Now, the biggest advantage of blockchain is that it has a built-in security layers within the blockchain architecture, right? And that gives you a huge advantage when you're comparing it to traditional client-server applications, whether you're doing a mobile app or whether you're doing a basic web app for your use cases, right? In your traditional use cases, you have to factor security in within the design of your application, which means that you have to spend time and effort and development time to building the security layers in your application, and you have to probably procure security licenses, whether it's SSL and different security licenses, application level security, to make it more secure and to make your application secure, especially when it grows in volume of transactions. Okay, so how does blockchain address security in this case, right? So as we said earlier, blockchain comes from a distributed model, so it's inbuilt redundancy and decentralization. If you're, for example, in a public Ethereum or Bitcoin, if any nodes of the Bitcoin network goes down, right, the Bitcoin transactions still occur. It does not affect the service, the Bitcoin service. If I'm going to send you 5 Bitcoins, you're still going to get it as long as there's 1 or 2 nodes out there who are confirming and mining the transactions. So it's very similar to BitTorrent. Whenever you're downloading a file in BitTorrent, the file still continues to download as long as you have 1 or 2 seeders online who are seeding the bits of that file. Right? So whenever you're downloading any kind of content on BitTorrent, such as music or movies or any kind of files or applications, you have maybe 10,000 seeders out there and leechers. And whenever you're downloading, it downloads bit by bit from each of those seeders. As long as these seeders are online and connected, you're still going to continue receiving your download. If some seeders go offline, you're still going to get your download. It just might be a bit slower, right? So disaster recovery is addressed and built into the system, which means any node of the application that goes down, your application is still up and running because it's completely distributed, right? It has high availability because of the decentralization model or the distributed model. Any number of nodes can go down without impacting or affecting the blockchain application. Any record. So here you got So here you get any record of the transaction can be verified by anyone openly in the case of a public blockchain, right? If you're deploying an application on a public blockchain such as Ethereum or even on Bitcoin on the public mainnet, then that means your transactions are going to be available to be seen on the block scanner, right? We'll talk more about that in the next section on security. In a private blockchain, records are permission based, which means that you have selected parties which you give authorized access to. You'll be able to see those records in the case of a private blockchain. It's easy to audit any transaction and the trail of it, right? Blockchain is designed to make it very easy for you to be able to track and monitor and see the transactions on it, right? It was designed that way specifically to be able to remove the possibilities of fraud or kind of investigation. So this is why we're saying blockchain has major advantages when it comes to security, because the security is built into the network. You don't have to go and do a DR site for your application, or disaster recovery, or replication of your infrastructure in a separate in a separate data center or separate cloud architecture, because security is built into the network. Okay, a simple truth about hacking, right? So blockchain helps reduce the risk of being hacked. Security encryptions provide easy exposure. Now, the security, we'll talk more about the different security layers in blockchain, such as the SHA in detail, and the cryptography, asymmetric cryptography in the next section. But however, just keep this in mind, right? In any given model, in any given scenario, you cannot eliminate hackers from happening, or bad actors or malicious actors from committing wrongdoing, right? There are always going to be people who believe that they can outsmart the system, which they can actually, who they believe that they can get away with things, or they believe that they are smarter than the people involved, and they can actually get away with certain things. And hacking is just one of those areas or professions. So there's always going to be hackers. So you cannot eliminate that threat, right? There's always going to be people who are with ransomware and so on. This is the nature of technology. As you advance in your defenses, the hackers also advance in their attacks. However, what you can control is to make it very difficult for hackers to try to hack or intercept your application. And if they do commit any fraud or malicious activities, they're going to be easily exposed. So you're increasing the risk of them being exposed. Those are the two main aspects that you can consider when it comes to cybersecurity and when it comes to defense against potential hacks. So blockchain helps make that possible, right? The way that the system is designed, and the architecture and the nodes and the transactions, is designed that to make it very, very difficult for hackers to try to be able to hack and intercept the application of the blockchain network. And specifically, if any attack occurs, it's going to be easily exposed. It can be easily exposed to hackers and those individuals for them to be able to be pinpointed by the application. That's the advantage that blockchain presents. This is part of the design mechanism that Satoshi did or designed into the application, into the blockchain network, specifically for that purpose, because he knew, remember, blockchain was designed in 2008 during the internet era, right? So the impact, the possibility of fraud and hacks was already there. Traditional banking systems were designed in the 70s and the 60s, right, and the 80s, way before the internet. So they were not designed with security in mind. And that's what makes a blockchain network a compelling technology to consider, because of these built-in security, transparency, and trust within the actual network, right? Okay, so the total benefits. So when you consider all these three aspects, security, transparency, and trust, these are the benefits that you gain, right? Transactions are immutable. They cannot be changed, modified, or deleted, right? This protects against fraud and malicious activities, and people want to be able to hide and transfer records. Asymmetric cryptography, private key, public key. This gives you security that you'll be able to access those records using your private key. And private key, public key is part of a very powerful cryptographic hash, which is a very secure algorithm used within the blockchain network. High availability and redundancy. No need for DR sites. It's built into the network. No ID is linked to the transaction or the accounts. This protects the identification of people and users, right? To be able to avoid hackers from being able to attack because of specific people who they are targeting. Potential attacks can be discovered relatively with ease because of the design of the blockchain network. It can be easily detect potential threats and hackers' attempts on the network. Transactions are verified and confirmed in real time, which gives it a faster settlement time and less errors during the during the completion of transactions, right? All these are benefits that we can gain from using a blockchain as an infrastructure, as a database, as a network for us to deploy your application on, versus the traditional client-server application where we have to build the security and all these factors into the application, which contribute to the design process, and it gives it a much higher cost. Okay, I'm going to leave it out here, guys, and I'll see you guys in the next lesson. Thank you for watching.